Hi, and thank you for joining. We are going to take a look at a unique group of trig equations, and what makes them unique is the way we simplify them. So here we go. We have sine x cos pi over 6 minus cos x sine pi over 6 equals 1/2. The unknown variable is x, and x appears in two different terms in the left side of the equation. The right side has just a constant 1 over 2. Now, whenever we solve any type of equation, we try to simplify them by combining the terms. And having x appear in two different terms, and not only that, but in the first term is hiding inside the sine, the second term is inside the cosine, it will make it difficult for these two terms to combine. So we are going to try to take a different approach, and I invite you to take a harder look at the left side of the equation and read the question. Read it out loud if that helps. So what we have in here is the sine of an angle times the cosine of another minus cosine of that first angle times sine of the second angle equals 1/2. So I hope that you have recognized the very famous popular formula that we have just learned actually. And it can be described as sine A cosine B minus cosine A sine B. So this would be the formula for the sine of the compound angle A minus B. And we are going to use this very same formula to simplify the left side of the equation. So we're going to have sine of x minus pi over 6 equals 1 over 2. So the entire left side made of all these terms is equal to sine of x minus pi over 6. Now, just like we solved the previous equations when we had a multiple of x inside the sine, in this case, we have an expression inside the sine ratio. So our angle is not made of just a single variable, but a binomial expression. We are going to redefine the domain. So if the domain for x is given to be between 0 and 2 pi, the domain for x minus pi over 6, I'm going to rewrite this down in here. So for x minus pi over 6, we have to search within the domain negative pi over 6 and then 2 pi minus pi over 6. Which means that the angle we are solving for, x minus pi over 6, will be between negative pi over 6 and 13 pi over 6. So 13 pi over 6 is a simplified form of this. So let's get started to solving the equation. We are isolating x minus pi over 6. And we are going to find all the angles x minus pi over 6 with a ratio of 1/2. Simply use the calculator for it. And if your calculator is set to degree mode, then it will give you the answer 30 degrees, which we obviously have to convert to radians since our domain is described in radians. So let's not solve yet. Let's try to find out the other angles that are angles x minus pi over 6 that share the ratio of 1/2. So we're going to do this by drawing the angle on the Cartesian plane. Here goes the angle pi over 6, which is in the domain of x minus pi over 6. And the other angle with the same sine ratio will be the one that we build by reflecting the terminal arm about the y-axis. So these are the two possible angles that we can draw with a ratio of 1/2. So next we will be reading the solutions. So if the first solution for x minus pi over 6 is pi over 6, the second one will be this angle, the green angle, which is basically the entire pi, take away the pi over 6. So that is 5 pi over 6. So I'm going to color code them actually, because that kind of helps sometimes. So here goes the angle pi over 6. And this one here would be the angle 5 pi over 6. Now remember that we are looking for angles from negative pi over 6. There is no terminal angle in here. So that means that we don't have any solutions in the negatives that we can read. So no solutions in this quadrant. And 13 pi over 6. And it seems that both angles are within the domain described. Once we find the two angles, we can determine the value of x. We find the value of x by simply solving for x each equation. So for the first one, we'll have x equals pi over 6. Take negative pi over 6 to the other side, becomes positive, and this will give 2 pi over 6, which simplifies to 1 pi over 3. And from the second equation, we'll get 5 pi over 6, and then plus pi over 6, which equals, let's be consistent with colors, 6 pi over 6, in simplified form, pi radians. So as you can see, pi over 3, both pi over 3 and pi, are in the domain of x. And we're going to say that the two solutions are x equals pi over 3 and x equals pi. And we'll box them up. And now let's take a look at the graphical explanation of the solutions that we just found. As you can see in here, we have the graph of sine of x minus pi over 6. And the way we know it is because this is translated pi over 6 radians to the right. This is the value of y equals 1/2. And you can tell that the graph y equals 1/2 has intersected the sine of x minus pi over 6 at 2 points. And the 2 points are at x equals pi over 3 and x equals pi, which